Okay, so we have been talking about lines all this chapter so far, so we are going to continue to be talking about lines. And we are going to be doing that by talking about what we call arithmetic sequences. And don't let that confuse you. We are still talking about lines. One of the other important components that we're going to be using is also slope. Slope is going to become pretty important when we talk about sequences as well. So just a sequence, like a general sequence, is just an ordered list of numbers. So it does not necessarily follow a pattern. So that means that I just am going to have a list of numbers in order. So it could be something like 2, 13, 7, 9, right? It's just a list of numbers that don't follow any sort of pattern, but they are just listed out. That's all a sequence is. Second thing is a term. So a term is each number in the sequence. So really what you can, another way to say that is it's the position of a number in the sequence. And so that just means, like, is it the first in the list? Is it the third? Is it the fifth? Is it the 10th? Right? That's what that means by term. We have some new notation involved around that. So I'm going to write it out and then we'll kind of talk about it. So I would have a sub 1, a sub 2, a sub 3, and I'm going to put in a sub n, and we'll talk about it. So the small number that happens on the bottom right-hand side of the A tells us what place it is, what position that value is in the length of my sequence. So if I have a sub 1, this is the first number in my sequence. A sub 3, this is the third number in my sequence. So when I'm talking about a sub n, what that is it's an unknown number in my sequence. So it's just any number in my sequence is going to be a sub n. I can plug anything in there for it. So then we've talked about sequences. There's a specific kind of sequence that we're talking about, though. It's called an arithmetic sequence. And an arithmetic sequence is a sequence where the difference between each pair of consecutive terms is the same. So in other words, this follows a pattern, and it's constant. So for example, 2, 4, 6, 8, right? It's pretty obvious what that pattern is that I'm using. I'm increasing by 2 every single time. So that is an arithmetic sequence. It's a sequence where the difference between each pair of consecutive terms is the same. So that difference then between those two consecutive numbers is what we call the common difference. The common difference is the difference from one term to the next. So another way to say that is it tells us to move up or down the same amount. Now you should be thinking to yourself, Miss Olson, this sounds really familiar. We've talked about something similar to this. If we go up and down by the same amount every single time, when we're talking about lines, what we're talking about is the slope, right? So when you think about common differences, you're going to think slope. It's the same thing. All right, let's do some examples. So here we have the position and the term. So the position that it's in the first position. This would be a sub 1. Second position would be a sub 2, a sub 3, a sub 4, and the nth position would be a sub n. Something to make sure that you're paying attention to too is that these can kind of look like 9s if you don't draw them carefully. So make sure that you can tell that they're a's and that they're not 9s. So then the next step is to look at, well, how do I get from one to the next? Well, 6 to 12 is plus 6. I don't know why I wrote plus 2. It's plus 6. From 12 to 18, also plus 6. 18 to 24, plus 6. So my common difference, I'm going to abbreviate that as CD. My common difference then is 6. I'm increasing by 6 every single time. So then the important part of this, what I really want to pay attention to is, well, how do I get from my position to the number. How do I know what number is in which position? Well, if you look at this, I go from 1 to 6, I multiply that by 6. In my second position, from 2 to 12, I multiply by 6. 3 to 18, multiply by 6. So I'm taking the position that my number is in, where is it in my sequence, and then I multiply that by 6. So if I want to figure out my nth term, my nth value, I'm going to take 6 times n in order to figure that out. So if I wanted to figure out what is a sub 10, what number is in my 10th term, well, I'm just going to take 6 times 10. It's 60, right? So what this allows me to do is to figure out what number is in each place in my sequence. Let's look at the next example. Write the next 3 terms of the arithmetic sequence. So I go from -2 to 6 to 14 to 22. So -2 to 6 is plus 8. 6 to 14 is plus 8. 14 to 22 is plus 8. So that means that my common difference is 8. The next 3 numbers then that I'm working with, so I'm going to add 8 to 22, would be 30. Next one would be 38. Last one would be 46, just adding 8 every single time. All right, this is where it's going to start to become a little bit more complex. So I've been given this arithmetic sequence of 2, 5, 8, 11, 14. It's asking me to graph it. So first thing that I want to do is I want to list these out as like a table. So I would have a sub 1, let's get this here, a sub 2, a sub 3, a sub 4, and a sub 5. Okay, so then I would have, this is 2, 5, 8, 11, 14. Okay, so here is a list of my sequence broken up by what term it's in. So first thing I could do is I could look at, well, what is my common difference? Well, 2 to 5 is plus 3, 5 to 8 is plus 3, 8 to 11 is plus 3, 11 to 14 is plus 3, right? So my common difference is 3, but now I have to think about, well, how am I going to graph this, right? So it may not seem that intuitive right now, but how would you think that I would graph this? So I'm really only given one set of numbers, and then I have these different a sub 1, a sub 2 things that aren't numbers. There's letters there, but they do correspond to numbers, right? So a sub 1 is my first position. So the first point that I'm going to be working with is the point 1, 2. Right, so I'm going to come over here, 1, 2 is on my graph. The next point then would be 2, 5, right? So I'll come over here, 2, 5, and so on and so forth. So then it would be 3, 8, right? 4, 11, 5, 14. And if you notice, this is increasing at a constant rate, right? We can draw a line through here pretty easily. So what do you notice? Well, what we can notice is that arithmetic sequences form lines. And that's good for us because we know how to work with lines. We know what to do when we work with lines. Okay? Let's look at the next one. So I'm going to give you some points. First point is going to be 1, 5. 1, 5. Second one is going to be 2, 7, 2, 7. Then we'll have 3, 9, 3, 9, 4, 11, 5, 13, and then 6, 14. And then let's fill these in. So I have position a sub 1, a sub 2, a sub 3, 4, a sub 5, and a sub 6. Okay, so my first point was 5, 7, 9, 11, 13, 14. So the question that this is asking is, does the graph represent an arithmetic sequence, and explain? So I know that arithmetic sequences need to form lines, right? So if I look at this, I can see that, well, these are straight, right? And then, oops, I go off a little bit over here. So I can decide right now this is not arithmetic. And the first reason for that is that it doesn't form a straight line. That's the first reason. The other reason is that my common difference is not constant. So it looks like it's going to be, right? So I go from 5 to 7 plus 2, 7 to 9 plus 2, 9 to 11 plus 2, 11 to 13 plus 2, 13 to 14 plus 1. It's not constant. My common difference is not constant, so this is not going to be arithmetic. Okay, so all that's well and good. We have been looking at graphs, been looking at tables to figure out different sequences, but sometimes, most of the time, where this gets to be helpful is when we can talk about them in terms of an equation. So I want to find the nth term of an arithmetic sequence. So this is telling me to write an equation for the nth term of the arithmetic sequence 7, 3, -1, -5. Okay, so I've been given 4, so a sub 1, a sub 2, a sub 3, a sub 4. I want to get over to a sub 30. Would you like to just keep counting until we get down to a sub 30? That doesn't sound like very much fun. So we're going to do a shortcut. So I've got 7, 3, -1, -5. So there's a formula that I can use when when I'm talking about arithmetic sequences. Oop, that doesn't help either. Okay. And the formula that I'm going to use is a sub n equals a sub 1 plus n minus 1 times d. So what do you suppose this d stands for? Well, the d is going to be my common difference. So I need two pieces of information to really fill in this formula. First piece of information that I need is, what's a sub 1? Well, my a sub 1, my first term in this case is 7. My d value, my common difference, I go from 7 to 3, that's minus 4. 3 to -1 minus 4. -1 to -5 minus 4. My d value then is -4. Then I can just plug these into my equation. So I would have a sub n equals 7 plus n minus 1 times -4. Now, when we are dealing with distribution, we're used to seeing something like 2 times x minus 1, right? And then we would know, well, I'm going to take the 2 and I'm going to distribute it. We're good to go. I'm going to say something that may blow your mind, may not, we'll see. It does not matter which side of the parentheses the number is on, you're still going to distribute. So in this case, my number, my -4 is on the right-hand side of my parentheses. Doesn't matter. I'm still taking the -4 and I'm distributing it to both terms. So when I do that, then I have a sub n equals 7 minus 4n plus 4. Combine like terms, then I have a sub n equals -4n plus 11. And I can check this to make sure it works. So if I look at my position 2, my second position, if I plug in 2 for n, 2 times -4 is -8. -8 plus 11 is a positive 3. Right, so I want to figure out, well, what's a sub 30? Well, a sub 30 just means that I'm going to plug in 30 for n. So I'm going to take -4 times 30 plus 11. So that equals -120 plus 11, which is going to equal -109. See how quick and easy that was? We didn't even have to count up. We can just do a couple steps and we get there. So I want you to go ahead and do the second one on your own. So write an equation for the nth term of the arithmetic sequence, 6, 9, 12, 15, then find a sub 60. So if I were doing this, I would want to start by kind of making a table. It helps me kind of visualize what's happening. So a sub 1, a sub 2, a sub 3, and a sub 4. I've got 4 of them that I'm working with here. 6, 9, 12, 15. So my first step is I want to figure out, well, what is my common difference? Once I figure that out, then I can just use this equation up here. So go ahead and do this next example on your own, and then you can come back and check your answer with me when you're done. All right, so you should have gotten the equation a sub n equals 3n plus 3. And then when you plug in a sub 60, you should have popped out 183 for that. All right, let's go ahead and go to the back page. Real life problem. So I have that Juan saves $12 in the first week of the year. He will increase the amount he saves each week by $4. So let's just think about this, right? So week 1, he had $12. If he increases by $4 every time, how much does he have after 2 weeks? He would have 16, right? After 3 weeks, he would have 20, so on and so forth. So if I plot this out, this is my a sub n, right? And then my common difference is going to be a plus 4. So if I want to write an equation, my a sub n is going to be my initial value, which was 12. A sub 1 is 12 plus n minus 1 times 4. Distribute my 4 to both places. A sub n equals 12 plus 4n minus 4. If I combine my 12 minus 4, I get a sub n equals 4n plus 8. And that is the arithmetic sequence that represents the situation. So now it wants me to graph this. And so that's where I kind of have to think about points. Well, I kind of have points up here already, right? My first term goes to 12. My second term goes to 16. My third term goes to 20. So I can go 1, 12, 2, 16, 3, 20. My line is going to look something like this, right? There's the graph of that situation, increasing pretty steadily. And then the last part C, is it says that Juan's goal is to have $68 in 1 week. So he's saving $4 more every week than he did the previous week. I want to know at which week is he going to save $68 that week. Well, if you remember, our equation is a sub n equals 4n plus 8. Well, what does n stand for? My n, in this case, is going to be the week number, right? So at 1 week, I have $12. At 2 weeks, I have $16. So really what I need to do is I need to solve for n in this case. So I'm given that the value at n is going to be 68 equals 4n plus 8. And if I solve for n, that's just going to tell me how many weeks it's going to take me. So I'm going to subtract 8 from both sides. We get 60 equals 4n. Divide both sides by 4. I get that n equals 15 weeks. So after 15 weeks, Juan will have saved $68 in 1 week.